Alright, so you're working on your projectile lab. And let's just start from the beginning. You started with your marble launcher with the photo gate. So the photo gate here, of course, had the laser going across of it, and there's the barrel of it with the block that's attached to, and then the pull thing, right? So you got your photo gate. The photo gate, when you launched your marble, gave you a time. It was a very small time, right? That time was because a marble was, going through it. That marble had a width. That's delta x. That's your marble. Well, these two pieces of information together give you a velocity. I expect that most groups at this point in time have got that velocity figured out. You should have three distinct velocities where you get three distinct pullbacks. You need to be very consistent about this. Now, once you've got these velocities figured out, you no longer need to be recording with the photo gates. Okay, then it goes into all prediction mode. You're going to predict to go in a certain place, and you're going to shoot it, and you're going to test and see where it lands. So now to get that prediction, so it's not just a marble launcher, but it's also, there's my table there, right? Well, you know that you've got a delta y going on there. You got a height that you can measure in meters, not centimeters. With that height, you can use this equation that we like so much. Delta y equals 1/2 gt squared. This t here is fall time. Now, the other equation that goes right along with it that we were such big fans of was this. Delta x equals velocity x times time. The velocity was gathered from your photo gate. The time was gathered from the height of fall. This should be the same for every trial, but your three different predictions will change because these velocities will be increasingly faster, right? So what's going to happen? Let's focus down here now. What's going to happen is, depending on it being fast, medium, or I guess slow, right? You're going to have three predicted landing points. Well, you're going to go get the landing paper. That's that carbon paper. It's like when recommendation day paper. It's got two layers. And in the middle of it, you're going to put an X. A T, a landing point. And let's say that your prediction is 1.2 meters. You're going to put that landing point right there on the floor at 1.2 meters. And you're going to shoot. And you're going to get a spot there, and a spot there, and a spot there. And maybe even a couple more. Maybe you shoot like 5 shots because that's just good science to shoot multiple shots there. Well, then you got to make sure you label these. Trial 1, Trial 2, Trial 3, Trial 4, Trial 5. Like, go ahead, write on with a pen. Small mind you. So then when you take your paper and just move it to the next spot and you shoot again, you can mark those as separate trials. So you can record all your data and do the third one. You can record all your data, and then if you can get that recorded, that's a pretty big step. Then we can start figuring out percent error and whatnot. But just getting the prediction, you're not shooting it and saying, oh, it lands here, we should put the paper there. You're saying mathematics say this time and that velocity tell me to put the paper here, and then you try to hit it. Okay, mathematically predict and then put the paper there. Good luck.